Welcome back to the Backup Power Project. Now, in the last episode, we learned that this very inexpensive Harbor Freight 4000 peak and rush inverter could not run my gas dryer. So it runs this well pump, it runs my furnace, runs my clothes washer, lights up the house, runs the refrigerator, but it just doesn't run the dryer. So today, we have a more powerful, supposedly, more powerful 8,000 watt inverter that we just purchased from Amazon. We're going to sub it in here, see if it'll run the pump, because I don't trust the specifications. Hopefully I'm wrong. And then if it runs this well pump, like that one does, we'll try it on the gas dryer and see if we're all set. Now remember, the Backup Power Project is all about continuity of modern convenience. In a grid down situation not coming back anytime soon, we not only want water in the house, we want to be able to run that furnace, keep our pipes from freezing. We want to be able to wash and dry clothes. Of course we want lights. That's easy. You can do that even with something like this. Not a big deal. We want to be able to charge our equipment. We want to be able to run our TVs. That's all simple. The tough stuff are these induction motors. And this guy, the little engine that could, recently on sale, it was the fall of 2023, I saw the latest version of this, $109, unbelievable. Does everything I want except run the gas dryer. So we'll try a bigger one today, see if it works. Alright, got this from Amazon. Has very impressive specifications, but the first thing I see that's causing me to doubt those specifications is this rinky-dink connection cable. This is supposed to be 4,000 watts, 8,000 peak. How are we getting that kind of power through this, what looks like it might be a AWG4 cable? I have my doubts. But we'll see. So, the brand name, I really don't know how to pronounce this. I hate it when someone has an unfamiliar name and they don't tell you how to pronounce it. They are going to make you guess. Oh, for example, my last name is Pina, P-I-N-A, just like the word peanut without the T. How do you pronounce that? I don't know. And apparently, neither do they. Because on January 14, 2025, 2 weeks after I had purchased the inverter, I sent an email, a very polite email, a very respectful email, to the tech support address given in the owner's manual. It's not given on the website, but it is given in the owner's manual, and you'll see it here. And I mention in this email that I'm reviewing the product for my YouTube channel. I give the link to the Backup Power Project, and I respectfully say I don't want to mispronounce the product name. They never answered. So 2 weeks later, I asked the question on Amazon. And this time I ask two questions because I am thinking that the tech support email address is bogus. So I ask them, in your Amazon product offering, you mention 24 months warranty. Contact us by email. Well, what's the email address? Because you don't give it here on Amazon. So I ask that question. And of course, I also ask, how does the manufacturer pronounce Jarxioke? What's the proper pronunciation? And you'll see their answer. It's dated January 21st, 2025. They don't answer either question. Instead, they ask me what problems I'm having. So I can't get an answer from sales. I can't get an answer from bogus tech support. So I decide I'm going to go directly to the manufacturer. So I look up some info on the manufacturer, and I find out that the manufacturer spells their name a little bit different from the trademark on the product. And you'll see here that the manufacturer's name is Jiaoxiake. So that's different. So I look up the trademark. And on that page, we learn that the wording Jarxioke has no meaning in a foreign language. So apparently it's a nonsense word like Jabberwocky. That being the case, I guess you can pronounce it any way you want. Why couldn't sales or tech support have told me that? So two things so far. What's not to like? Don't like the fact that you don't tell me how to pronounce your name. Don't like the fact that I have an undersized connection cable. But okay, we'll see. I do like the fact that it has a remote. All right. Here's another thing I don't like. I bought it anyway because I want the power. This has a mounting bracket here in the front. And that mounting bracket is going to preclude you, or me, from plugging in a right angle power cord. Now my pump has a right angle power cord. Either my washer or my dryer, one of them has a right angle power cord. My window air conditioners all have right angle power cords. So in order to use those appliances with this big inverter, I would need some sort of adapter to go between here and the power cord. That's crazy. Don't like this. Poor design. But I'll accept all of that if it really has that much power. All right, let's hook it up and see what it does. Wait a minute. Beforehand, we're going to look at another thing. These are 15 amp outlets. Now, in the United States of America, 15 amp outlets. How do we know that? 20 amp outlets have a little cut here. They have a groove. These are 15 amp outlets. So in the US, 15 amp outlets are limited to 1800 watts. And you calculate that. 120 volts times 15 amps. You do the math. It's 1800 watts. How do you get 4,000 watts out of an 1800 watt outlet? Not going to happen. So immediately I'm thinking that this is really not a 4,000, 8,000 watt inverter. I'm thinking you've got a 2,000, 4,000 on this side and a second 2,000, 4,000 on this side. And that would mean that they're only exceeding the 1,800 watt capacity by 200 watts here. And this whole bank would be limited to 1,800 watts. This bank would be limited to 1,800 watts. That would mean you've really got a 3,600 watt capacity. 1,800 on this side, 1,800 on that side. Well, that's how the other one works that I have now. This looks like it might just be two of those. The other one is the little engine that could.
I think I can, I think I can, I think I can. I think I can, I think I can, I think I can.
It's overperforming. It provides a lot more power than advertised. It's amazing what it can do. That pump draws 4,700 watts on startup. It's only rated for 4,000 peak. The little Harbor Freight inverter runs it fine. This one's rated 8,000 watts peak. If you're just looking at that, there should be no problem running the pump. But now that I'm looking at this, I'm really wondering. Well, let's find out. I hope I'm wrong. I really hope I'm wrong. I want this to work. So for the benefit of folks who've not seen any prior episodes, I guess we should prove that this little inverter can actually run this pump. Now I've got the pressure switch here, shows only about 10-15 pounds of pressure, and this is a 30-50 cutoff switch, so the pump is calling for water. Now I had unplugged it from the outlet and I have it plugged into the inverter, so the minute I throw this switch it should start pumping water. Let's see if it's going to work. Here's our power level, consuming about half the power of the inverter. No problem running this pump. It's going to pump it right up. Okay, we're showing this in real time. Pump cycle now is between 90 seconds and 2 minutes. Now I just ran a bunch of water out of the system, so it should be closer to 2 minutes. And this little inverter, recently on sale for as little as $109, that'd be the Jupiter latest model, works every time. I bought this back in 2015. It's 2024, it's late January, excuse me, it's 2025, late January. So this is 9 years old, runs like a champ. Pretty much runs everything in the house except for the gas dryer. And that's why we're looking for a better one. Now we don't know if the new inverter can even do this. So that's why I just showed how this little cheap Harbor Freight inverter, nominal voltage 115 volts, works. It works great. It just doesn't run my gas dryer. Gas dryer draws over 5,000 watts. And while this is underrated, overperforming, it's only rated 4,000 watts peak. It can't do 5,000. However, one of the best deals going, in my opinion. Now let's just look at the backup power system, because we're going to be putting that new inverter in here. What do we got? I'm not using the dinky cables that came with it. I'm going to use these exact same cables. These are 1/0 cables. Easily handle over 100 amps. When this inverter is running, like right now, if we had a clamp meter here, you'd have seen about 90 amps on these cables. These are 100 amp hour AGM batteries. We've now got 3 of them in here, 300 amp hours total. What are these? These are the charging cables from my Harbor Freight solar panels. No problem keeping these batteries charged. What are these little ones? That's my 12-volt lighting system. We have 12-volt lights all over the house. If the power goes out, my lights stay on, and I don't need the inverter to run them. All right, let's go look at the condition of these batteries. We'll check our solar charge controller. So after that run, the sun is out. We see a little arrow pulsing here, so it's being charged. And my battery bank 12.6 volts after one run. Okay, so it works. There's no question about that. Plenty of other episodes showing everything. Let's see if the new inverter can at least run the pump, and if it does, then we'll take it over to the gas dryer. Okay, I've got the Harbor Freight unit disconnected. Now, one of the things I like to do is mark what size nut you need, because with so much equipment, I can't remember everything. But so these are 10 millimeter nuts, and there's also a 10 millimeter on the bottom hex bolt. So you need two. You need to hold the bottom with a 10 millimeter wrench while you're unscrewing this with a ratchet or another wrench. And lucky for me, the new inverter also uses 10 millimeter, and it's going to be easier to put this in, because unlike the Harbor Freight unit that has a bolt on the bottom here, the bottom is part of this standoff, so you really only need one wrench or one ratchet from the top to secure this. It also has these guards that go in after the fact to protect your connections. Pretty nice. Now, regarding the studs, you can get cables that have 3/8 ring terminals and 5/16 ring terminals. I've been using 5/16 on these, and since it's the same size, they're going to fit this perfectly. So right now, looking like an excellent upgrade. If you had a 3/8, then there would be a lot of play here. The ring term, we've shown that before. Much too big, too much play, not going to make good contact. So right now, looking like an excellent swap in. Let's see how it goes. Now, these studs are really only 1/4 inch. So even my 5/16 kinds of swims on here, I noticed that the new cable provided with this inverter does have 1/4 inch ring terminals. So somebody is aware of this and actually provided the right size ring terminal. That kind of gives me hope that these people know what they're doing, because all the other inverters, what they provide is completely inappropriate. Those are the other ones that I've tried. So that's a very, very good thing. I'm using the same cables I used on the Harbor Freight inverter for fairness. So if this works or doesn't work, you can't say, well, you didn't use the right cables, or same battery bank, same cables, same everything. Boy, these ratcheting wrenches sure are handy. And cheap too. 10 millimeter. Alright, that's pretty tight. I don't want to kill it here. Now we're probably going to get a spark, and I want to make sure the inverter is turned off. But even with the inverter turned off, usually in my experience, when you attach the second cable, you get a spark. That's normal. Every inverter I've ever tried has done that, including my Harbor Freight inverters. So make sure that this power switch is off. It is on off now. Alright, triple checked here, it's off. Okay, prepare for spark. Yeah, that's what happens. Kind of frightening if you're not expecting it. I guess that's why electricians have nicknames of Sparks or Sparky. Doesn't mean anything's wrong, it's just the way it is. Alright, let's get this tightened down. Alright, that's pretty tight. I don't want to break anything. The guards they supply want these cables to come straight out the back. But even though these are just 9-inch 1/0 cables, I'm not going to be able to go straight out the back in this setup. Got to be very careful not to touch positive. I'm going to leave that alone. It's tight enough for this test. Okay. Let's turn the thing on, see what happens. On would be up. Okay. Looks like the solar panels have charged my battery bank back up to 13.5 volts. You can see that right here on the left. Where 60 hertz shows that the battery is fully charged here. Those Harbor Freight panels do an excellent job of keeping these batteries fully charged. I've only got 2 connected at the moment. 120 volts, that's about right. 60 hertz. Well, everything looks good. I'm going to have to draw some water because we just filled the tank to see if this thing is going to run this pump. Alright, let's do that. Okay, now here's our first problem. This mounting lip prevents me from plugging this all the way in. Well, let's see how far I can get it. Well, I was wrong about that. The design of this particular plug is just enough to get it plugged in. So that's not an issue. Let's hope everything else is not an issue. I really want this to work. So while we're waiting for the tank to draw down, I'm going to have to draw some water. I thought we'd make some other tests here. Now you can see that the Inverter is off. I've got a USB cable plugged in and a little voltmeter at the other end of the cable, and you can see the charging voltage. Of course, we're not drawing any amps at the moment because we've got nothing plugged in, but charging voltage is present even when the inverter is off. That's how the Little Harbor Freight inverter works. But most of the other, in fact, none of the other inverters I've tried work that way. So this is a very, very good feature. We have charging voltage even with the inverter off. That means the inverter's not drawing any standby power, that at least the display's not on. Definitely off. We have phone charging voltage. Excellent feature. Starting to like this. I hope it works. Okay, so here's another test that we can make while we're waiting for the tank to draw down. Our line voltage today, January the 10th, 2025, is 121.5 volts. That's a little less than the last video we did. I'm going to disconnect this kilowatt, plug it into the inverter, and see what kind of line voltage it reports coming out of the inverter. Okay, so the kilowatt shows 120 volts, and the inverter also shows 120 volts, batteries at 13.5 volts DC. Get some light on this. 119.9, 120. So yeah, putting out 120 volts, just what it's supposed to do. So that's not a fake reading there. It's confirmed by the kilowatt. Wow, pretty good. Okay, so I've got this washing machine hose stuck into the dehumidifier drain. And we want to draw the tank down at least until we hear this pressure switch click. That would mean that the tank is empty and it's calling for water. Now, why are we doing this? Well, every inverter that I've tried wants the induction motor on before you switch the inverter on. So in order for that to happen, that switch has to be on, and for that to happen, we've got to draw down the water. Oh, my connection's leaking. But I did hear it click, so we should be good. Well, here it is. We're down to 0 pounds pressure. Tank is as empty as it's going to be. Power cord is plugged into the inverter. Hopefully I shut off the drain. Double check that. Turn on the inverter, see what happens. Moment of truth. What do you think? Place your bets. Yay, it works. Well, this is a first. This is the first inverter besides that 2000, 4000 Harbor Freight inverter that can actually run my pump. Now note what it's doing. Battery bank is down to 12.3 volts. We're still at 120 volts AC. Pump sounds fine. I don't hear any unusual noises like it's struggling. Battery bank is holding just fine. We're drawing 1200 watts here. I should have noted if it saw the inrush wattage. Well, we'll have to wait till next time. Now, one of the big differences, this is a pure sine wave inverter. So when we measure the power coming out of this, it should be as clean, if not cleaner, than the power line. The 2000, 4000 Harbor Freight inverter is called modified sine wave, and the total harmonic distortion is quite high on that unit. All right, let's measure this one, and then we'll measure the Harbor Freight next. Now, before we do that, I want to check something else. We're in the basement. The air temperature down here is 67 degrees Fahrenheit. We just ran this pump from 0 pounds pressure to a full tank. And this unit it didn't even get hot. It's showing 66 degrees. The cooling fan did not come on. Didn't even phase it. That's impressive. That's very impressive. Because other inverters that I've tried, they immediately turn on very loud fans. They can't do anything. So far, very, very impressive performance. All right, let's get on that THD. Now, to set up a baseline, I've got my meter plugged into a power strip. So I'm going to turn this on and we're going to measure our line voltage and also the total harmonic distortion on that voltage. So we've turned it on. Meter's turned on. We're at 122.6 volts. It's March the 5th, 2025. And our total harmonic distortion is 6.8%. That's running a little higher than it usually does here. Usually I'm in under 5%, so that's what I got today, 6.8%. Check our voltage again. 122.4 volts. Okay, now let's check these inverters. Okay, we're all set up here. Turn on the inverter. We get 120.4 volts. Let's see what the inverter says. 120 volts, 60 hertz. Battery's fully charged, 13.5 volts. Okay, my expensive amp probe is reading 120.4 volts. That's right on the money. All right, let's check the distortion. 0.6% total harmonic distortion. So that's slightly cleaner than the power line. That would mean that anything that safely runs on our clean grid supplied power should run just as safely on this power because it's even cleaner. Now that's important. Let's take a look at the modified sine wave inverter, then we'll also check a portable power pack. It's a good tight outlet. Okay, we've got the Harbor Freight unit back here. Okay, so we've got the meter hooked up to the Harbor Freight unit now, and the Harbor Freight unit is hooked up to a couple of 12-volt batteries that I have in this roll-around cart. So we're going to turn it on, and first we'll check the voltage. So our Harbor Freight unit, which is rated 115 volts, is doing 116 volts. That's pretty good. Now we'll check THD. Oh. .8%. That's right. Not 0.6%. 32.8%. Now that's typical of any gas generator. I would say most gasoline generators are in that range. Diesel generators are in that range. Inverter generators tend to be lower, might only be in the 10 to 15% range, but that's pretty high, 32.8%. Now, we know from experience that people run their appliances on gasoline generators when the power goes out, and I've run my appliances on this unit many times when we've lost power. It does not hurt induction motors like that. I am concerned, though, about sensitive electronics. I have a new inverter mini split. I would be reluctant to run it on dirty power like this, and I have an unbelievably efficient, relatively new, it's only a couple years old, LG refrigerator. I would also be very reluctant to run that on dirty power like this. So something to be concerned about. There's your big difference. 32.9% here, 0.6% here, even lower than the actual power line. Okay, now let's check a portable power station. All right, see where this is. Percentage of charge. 100%. Oh, should be good. Open one of these up. All right, we got it plugged in. Inverter power. Now we're still reading THD here, so we'll change it to voltage. 123.6 volts. That's pretty good. But look at your THD. 33.6%. That's about the same as the modified sine wave Harbor Freight inverter right there. It's dirty power. Now, I've run quite a bit of stuff off of this Die-Hard power pack. It runs my NutriBullet just fine. I am not sure I would want to run super sensitive electronics on it. But there you go. And that's the benefit of pure sine wave. Well, I can't tell you how impressed I am right now. This inverter had no trouble whatsoever starting my clothes dryer. And if you look very carefully at the display right now, we're showing a run wattage of 580 watts. We're at 120 volts, 60 hertz. My backup battery is holding at 12.4 volts. It's actually snowing up quite a storm out there today. Not a bright sunny day. We're out here in the mid-afternoon on a Saturday doing our laundry. I've got a 25-foot, I guess this is a 12 gauge extension cable. Let's follow it across the floor here. And here's the dryer. Running perfectly. Dryer cord is plugged in here instead of being plugged into the wall. Wow. Absolutely amazing. Inverter performs as advertised. We dried 2 loads of clothes that snowy afternoon. Dryer ran fine. Inverter never got hot. Fans never came on. Hardly dinged the batteries, too. The next morning, I just brushed the snow off the panels. I've only got 200-watt panels out right now. And when I checked later in the day, my 300 amp hour battery bank was up over 13 volts again. Very, very impressive. No other inverter I tried could do this. Okay, we have 2 other things to test. Now, here in the owner's manual, no load current, 4,000 watt unit, given as 0.6 amps to 0.9 amps. So I'm just going to round that off to half an amp to 1 amp. That means that if you leave the inverter on, even if it's not doing anything, it's consuming power. Obviously, it lights up, it's standing by, it's consuming power. Now let's say you have a 100 amp hour battery, so you can produce 100 amps for 1 hour or 1 amp for 100 hours, supposedly. And if you could draw all of that power from the battery, and we'll round this off to 1 amp, then that battery would be dead. Even though you powered nothing with this inverter, it would be dead in 100 hours. So that's 4 days. Your battery would be dead if you left the thing on. Now that's a very small amount of electricity, and your solar panels are certainly putting that much and a whole lot more back, but still, if you're not using it, it's a very good idea to shut it off. And that's where the remote control comes in. So the first thing we're going to do is actually measure the parasitic drain, and then we're going to see, also known as self-consume, then we're going to see how well the remote control works. Okay, so I've got my clamp meter. I'm going to turn the inverter on. We'll put the clamp meter on amps. We cleared this so that any residual electricity in the air has been cleared off, and it's at 0 amps at the moment. I'll put it right here on this red cable. Now I'm going to hit the hold button. And it's showing, but it's moving. 0.59 amps. Let's try that again. Cleared it. So it's around 0.6 amps. That's well within the specified 0.6 to 0.9 amps, so it's right on the money. So very low parasitic drain, very low self-consume. Nevertheless, when we're not using the inverter, it just makes sense to turn it off. So let's see how well the remote control works. And can we turn it off from upstairs, or do we have to be down here? That would kind of defeat the purpose. So let's see. All right, now the first thing, and they make a big deal of this in the manual, this switch has 3 positions: on, the middle position is off, and the lower position would be like an instant on position on a TV. This will activate the receiver for the remote control. And I guess we might want to measure to see how much power that's consuming. Let's try that. Okay, so remote control is consuming about 0.2 of an amp. At these really small currents, the meter changes. But obviously that receiver is going to consume some power, so it's not powerless. Now that's really nothing, because look up here. You can see the solar panels are generating 14.1 volts at the moment. So that's easily being replaced by the panels and then some. Most of it's just being discarded. But okay, let's just see if how well this remote is going to work. I'm going to press the on button. No problem. I'm going to press the off button. No problem. And unlike other inverters that I've tried, this wireless remote, it's not wired. This wireless remote works from upstairs. So in a prolonged power failure, you want to take a shower, you want to wash dishes, you want to just draw water, you want to flush the toilet, you can use the remote without running down here, turn the power on, and when everything is done, you're done using water, you're done with your shower, you're done with your dishes, you can just turn it off again. So this has to have a radio frequency component. It's not line of sight like others that I've tried. It actually goes through the ceiling up here. No problem upstairs. So yeah, really a terrific remote, works great. Works fine, has whole house range, don't have to run any wires, no crazy Bluetooth that keeps disconnecting on your phone like others that I've tried. It just works. Like everything about this inverter, it just works. Very, very impressive. So, what's my final assessment? Well, despite the fact that tech support is non-existent, and the fact that sales will not answer a simple question, the thing works perfectly. I have the highest respect for the engineers who designed this, for the factory workers who assembled it, and for the writers, for the people who put together the owner's manual, because it's all absolutely perfect. No fault to be found with any of that. Such a shame that tech support and sales are so pathetic. Now, is it going to last? Time will tell. For now, though, we're good. So I hope this helps someone. Thanks for watching.